Hello, this is Ms. DB, and today we're going to look at some special bisectors of triangles. There's lots of ways to make bisectors of triangles. We're going to look at the perpendicular bisectors and the angle bisectors of triangles and see what happens. It's really kind of neat what happens. There's a lot of vocabulary. Some of them aren't too bad. Concurrent just means happening at the same time, and the point of concurrency is where a bunch of things will intersect. The circumcenter of a triangle, we'll look at that, and then circumscribed, and then incenter of a triangle and inscribed. So you can see circumscribed and inscribed kind of go together. We'll see what those mean here. All right, since a triangle has three sides, it has three perpendicular bisectors. That makes sense because you can do a perpendicular bisector for each side. When you construct the perpendicular bisectors, you find they have an interesting property. All right, so first of all, remember that the perpendicular bisectors of a side of a triangle do not always pass through the opposite vertex. Let me just draw a little triangle here. Now, if you have a compass and a straight edge, you can actually construct the perpendicular bisectors without too much trouble, and you can see what happens. If we were sitting in a class, I would make you all do this with me, but we're not. So let me just construct the perpendicular bisectors by eyeball. Okay, so I constructed the perpendicular bisectors just by kind of a rough sketch. And you'll see that what happens, and you can do this for real with a compass and a straight edge, or you can do it in Sketchpad, Geometry Sketchpad. What happens is that these three perpendicular bisectors will intersect at the same point, which is called a point of concurrency. The three perpendicular bisectors are concurrent. That means they all intersect at one point. It's P in this picture down here. So it is called, that point P, where all three of those perpendicular bisectors intersect, is called the circumcenter of the triangle. This is an important word, the circumcenter. It's when the perpendicular bisectors intersect. It happens to be, there's a little theorem here that goes along with this, that the circumcenter is equidistant from the vertices. So it's a little bit crazy. What it's saying is that these red lines are intersecting right here at P, and where they intersect is equidistant. Oh, I did it wrong. I'm supposed to be the blue lines. I made this one on the red line. The blue lines are equidistant from the vertices. So P is equidistant from A, B, and C. So isn't that interesting? The circumcenter can be inside the triangle, outside the triangle, or on the triangle. It depends on what kind of a triangle you start with. If you start with an acute triangle, that circumcenter will be inside the triangle. If you start with an obtuse triangle, they still will all intersect at the same point. You will still get a circumcenter, but it'll be outside the triangle. And if you start with a right triangle, the circumcenter will be right on the edge of a triangle. So you could try it and find out. Now, here's something else about the circumcenter. The circumcenter is the center of a circle that you could circumscribe about the triangle. So if you took and made your perpendicular bisectors, there's one, here's one, that point, the circumcenter, would be the center of the circle, and this radius is the same everywhere, right? The radii is the same in a circle. So you could put your point of your compass here, and you could stretch out your compass so that it was that wide apart, and then you can draw your circle, and that's your circle that would be circumscribed about the polygon. So lots of good stuff about the circumcenter. All right, let's see what we can do with this for a problem. Now, I like to use some different colors for a circumcenter. I am going to make my perpendicular bisectors red. So they're only showing part of them here, because if you go all the way through your triangle, it gets really confusing. So here's the red perpendicular bisectors that are meeting at the circumcenter of my triangle. Now remember the theorem. The theorem says that that point, in this case they're calling it G, would be the same distance from A and from B and from C. These are the same lengths. So AG is equal to BG is equal to CG. They're all the same. And they want us to find CG. All right, here's something else that's really neat about the perpendicular bisectors. It creates all of these little right triangles. It creates a right triangle. Let me color this right triangle in here for you. I'm going to look at this right triangle because they gave us some information about this right triangle. They're telling us that this right triangle has a length of, it's one of its legs is 7.3 from here to here. The hypotenuse of this right triangle is 13.4. Let's redraw that right triangle. Oh, I don't have to. I thought I was going to get to do the Pythagorean theorem here, but I'm not going to have to because they're giving me that GB is 13.4, and they want me to find GC, and GC is equal to GB. We already wrote that up here. So therefore, it's just going to be 13.4. I thought we were going to get to do the Pythagorean theorem to find a missing side. You could, though, if that's what they were missing. Okay, this one says to find the circumcenter of a triangle with vertices, and then they give you the vertices. If you would get a problem like this, definitely graph it on some graph paper or in Sketchpad. Makes it way easier. Okay, so the circumcenter, remember, is going to be the perpendicular bisectors, and the perpendicular bisectors are all going to meet at the circumcenter. And in a right triangle, they're going to meet on the triangle. It's very easy to find the perpendicular bisectors of a vertical or horizontal line because, like the vertical line that goes through this segment down here will be the perpendicular bisector. So the midpoint of this line from 0 to 10 is 5. That's the midpoint. And I'm going to go straight up. There's my perpendicular bisector of that side. Now on the other side, the up and down side, it's a vertical line. The perpendicular bisector will be horizontal, so it's going to meet right here. Now I don't even really have to get too fancy about the perpendicular bisector of the slanted line because I know it's going to meet at the same place. So right there's my perpendicular bisector. That's the circumcenter. So they say to find the equations of these lines. They're doing more work than necessary. Y equals 3 and x equals 5. And then they intersect these. See, right there. So I didn't really have to know the equations of those to be able to find that point. And I did not have to find the equation of the line that would go through here. I could find the slope of that, and I could find the midpoint, and I could take the opposite reciprocal of the slope and all that. But you don't necessarily have to because it'll intersect at the other ones too. Okay, a triangle has 3 angles, so it has 3 angle bisectors. The angle bisectors of a triangle are also concurrent, and this point of concurrency is called the incenter. So remember, where the perpendicular bisectors come together, that's called the circumcenter. The incenter is when the angle bisectors come together. And guess what? When you make all of your angle bisectors, and in this picture those are the red ones, the point, the incenter, P, will be equidistant from each side of the triangle. So YP will be equal to YZ will be equal to PX. So if you draw a perpendicular line from each side to the incenter, those will be equidistant. Those will be the same lengths. So the distance between a point and a line is the length of the perpendicular segment. We did that last section. And that's where you will have to have the equidistant part. The incenter is always inside the triangle, no matter what. Whether you have an acute, an obtuse, or a right triangle, it always ends up being inside the triangle. And the incenter, if you make the incenter of a triangle, remember if you draw all of your angle bisectors, let me draw my angle bisectors. There's one, there's one, there's one. That incenter, that point right there, will be the center of a circle that you could draw inside that shape, inside that polygon or that triangle, that will just touch. See how it's just touching each edge of the triangle? That's called a inscribed circle. This circle is inscribed in a polygon, and it intersects each line that is the edge of the polygon at exactly one point. So that's pretty cool. All right, so here is a problem that says that MP and LP are angle bisectors. That means that there would be another angle bisector here, but they didn't draw it out. And that P then is going to be equidistant from side Q, or from side ML. They've got that marked, that it's 5. It will be also equidistant from this side and from this side. These will all be right angles, and they will all be 5. They want us to find the distance from P to MN. Well, if this is 5, then the other one's 5, because it's equidistant from all sides. So it's just 5. This one says to find the measure of angle PMN. PMN. They want the measure of this angle up here. Okay. So let's see. We've got that P is the incenter. I know this will be 5 if I need it. I maybe don't need that part. PL is the bisector, yep, of this angle down here. And it's marked that this is from here to here is 50. So this must be 50. I should change from yellow, huh? So this is also 50. So that's 100, this angle. We know over here that this angle is 20. And we know that the triangle sum theorem from last chapter says that there is 180 degrees in every triangle. So we know that altogether 100 plus 20 plus whatever angle M is 180. Which means that we have 60 degrees up here. But I don't want angle LMN. I want angle PMN, which was created when we did the angle bisector. So half of 60 degrees is 30. Hey, where did it go? They didn't quite show the answer, but it would be 30 degrees. Half of 60 is 30 degrees. All right, this is just one more little quick example before we move on. It says that QX and RX are angle bisectors. Find the distance from X to PQ. X to PQ. Well, I know that from X to Y is 19.2. And let's see, where would the right angle be? About right there. That means that this is congruent to this. They have equal length, so it's also going to be 19.2. That's all there is to that. All right, here's an application problem. A city planner wants to build a new library between a school, a post office, and a hospital. A school, a post office, and a hospital. You are supposed to make a sketch to show where the library should be placed so it's the same distance from all 3 buildings. So the towns are going to be the vertices of your triangle, and the circumcenter will be equidistant from each of those vertices. So you're supposed to draw the triangle, just draw the 3 points and then connect it, and then to find the circumcenter, find the perpendicular bisector of each side. The position for the library is the circumcenter. I'm going to show you this in Sketchpad. All right, I'm going to open Sketchpad. New. And I am going to graph 3 points, okay? I'm just going to make 3 points. Now what I want to do is construct the perpendicular bisectors of each of these segments, but first I need to connect them. All right, here's how you construct a perpendicular bisector in Sketchpad. You are going to select the segment that you want, and you go to construct. Oh, I can't construct a perpendicular bisector yet. I wonder if it's because it's not a line. Construct. Oh, there. I had to select the endpoints as well. Now I can construct a perpendicular line. But those perpendicular lines are not. Okay, I know what I did wrong. I'm going to undo this. Undo. Okay, first I have to construct the midpoint. There we go. Now I can construct a perpendicular line through the midpoint. Okay, that will be my construct perpendicular line. No, what did I do? I did parallel line. construct perpendicular line. There we go. Okay, now I'm going to repeat this without making so many mistakes for my next side. I'm going to select it, construct the midpoint, and then select the line segment and its midpoint and construct a perpendicular line. There it is. And then one more side to do. Construct the midpoint, and then select the line segment and the midpoint and construct perpendicular. There. Okay. The circumcenter is right there. See it? I can select my 3 perpendicular bisectors. There's my 3 perpendicular bisectors. I'm going to color them pink. And I am going to construct the intersection of those 3 lines, which will be the circumcenter. Construct intersection. Why can't I construct the intersection? It'll be right there. And see, even if I move my triangle, it doesn't change. Let me see if I can put a point there. I wanted my point to change all of them. But that's my circumcenter, and that's where I want my library to be. I want my library to be equidistant from all 3 of those buildings, the hospital and the so on. So, and you see, if you change your triangle to a right triangle, I'm trying to make it be a right triangle, it would be right on the edge of the triangle. If it's an obtuse triangle, the circumcenter is on the outside. And if it's an acute triangle, the circumcenter is on the inside. Okay, go back to my lesson here. Slideshow from current slide. Okay, so that's how you would construct it in Sketchpad. It's not bad in Sketchpad at all. And there it is if you were going to draw it by hand. You can also construct the in Sketchpad the Incenter. Let me do a new page. Okay, I'm going to make a triangle with 3 points, and I'm going to connect those with line segments. And now remember that the incenter is when you do the perpendicular, I mean not perpendicular, the angle bisectors. So I need to select an angle like that and then construct the bisector, the angle bisector. Okay, there's one of the angle bisectors. I want to do that with this one too. Construct angle bisector. And one more. Construct angle bisector. All of those angle bisectors will have a point of concurrency. Remember, the point of concurrency is called the incenter. And I don't need that point sitting here. The incenter is always going to be inside the triangle, no matter what kind of triangle you have. See that? And let's see, what else did we knew that the incenter would always be the same distance from the sides of the triangle. I can measure these, I believe. Let me try and see. If I want to measure from here to here, measure distance. Okay, 2.98. Now I'm going to measure from here to here. I had something else selected, so it didn't work. Measure distance. Oh, I'm doing it wrong. I didn't do the perpendicular parts yet. So these, let me color these. That's what I did wrong. These are the angle bisectors. Display color pink. Okay, and the distance from this point here to the edge has to be perpendicular from here to the point. So I would need to construct a perpendicular line. Whoa, why is there so many lines? Undo. I made too many lines somehow. I just wanted the line. I wanted a line perpendicular from this line to this line. I'm going to color this a different color. Okay, what I wanted to measure was from here to here. That's what I should have measured. Measure distance. Okay, now I'm also going to construct a line perpendicular from this segment to my incenter. And then I'm going to make a point here of intersection so I can measure it. And then I want to measure from here to here. That should also be 3.57. Measure distance. Yes, good. And then I'll do one more. Construct the line perpendicular from here to here, because that's how you measure distance. And then I need to put a point on there so I can measure it. And then I'm going to measure from this point to here. There. So they're all the same. The green lines are showing the distance from the incenter to each side. And the pink lines were the angle bisectors of the triangle. And no matter what kind of triangle I have here, how I change it, the distance will always be the same. That's what the theorem says. So that's kind of cool. For your project for this chapter, you're going to be using Sketchpad as well. But going back to our slideshow, I think that was the last one we had to do, was making the building. Yep, that's it. So good luck, and try the Sketchpad tools and see if you can make the circumcenter and the incenter. It's kind of fun to do. All right, thanks a lot. Have a great rest of your day.